shit laughing
it's better to just like, I feel like a terrible laptop is like in the 300 to 400.
Well, and this was also, I guess, 12 years ago. So
okay,
it makes some sense.
Right. Okay. Cool.
To definitely come down. So that's true. Right. So it was like just a piece of shit laptop. That's a good place to start. And when you are actually doing something of value,
I mean, they have a full.
It's a good point. Like.
So like I
let him actually reach the ceiling doing like maybe some coding stuff or something, such that he like wants it and appreciates a better one. I really like that. Yeah, and also if you get worse hardware, it almost like encourages you to go get split because like you get more out of it. So I think that's actually really great.
Everyone else is hard to get.
All the companies. So I highly recommend it for another person. You know, like the kids are good.
Who is also in the first one want to go. He never goes in. And so it's like all the
kids that have like something to learn to code also like universally had Chromebooks, and it's always been like theoretically you get Linux on them, but it never worked for me to get Linux on their Chromebooks.
Just because I'm more of like a
shitty
learning.
It is. It's weird.
Thank you. It's worth it. There's just something that doesn't happen over the
People keep coming. Like there were like 5 people going back to their cars.
Well, it's
because Eric had 15 people in LinkedIn. Okay. So thanks for coming, guys. Everybody found the pizza. The bathroom is back where we came in, straight back past the elevators. There's a hallway. You have to follow the hallway all the way to the end into the bathrooms. If you have any need. We're gonna get started. There are 5 people that I'm sure more will come. Got plenty of chairs, I'm not worried. So welcome to Lightning Talks. Is this anybody's first Lightning Talk? Meetup. Good. Well, how Lightning Talks work, we just put out an open call, and anybody who has anything to say gets to talk about it. So if you're like me, you may have prepared a presentation. If you don't, but you have a side project you want to share, you are more than welcome to look up GitHub or whatever you want to on my computer. You didn't bring one, or you can.
I don't know if we
meet.
This
is the Wi-Fi. So if you brought your computer and want to share, join the Wi-Fi. And then I will give you the link to join the meeting. That is the most convenient way to share your screen. Did anybody besides me and Chris, Eric, did you bring a talk?
Yes. Sorry, have we started? I'm sorry.
Well, not formally.
Okay.
We don't formally start until somebody's speaking presentation. So you brought a talk. Did anybody besides me and Chris and Eric bring a talk? What's your name?
Chris.
Chris brought a talk. Okay, cool. Anybody else bring a lightning talk?
Chris is speaking prompt 2.
Does anybody have anything they want to share? If you get the desire to share later, it's fine. We'll get going. So we'll start with announcements now. If you ever go to a meetup and find yourself locked outside because the building will not allow us to unlock the doors, the best way to get in contact with an organizer is Forge Slack. You haven't joined Forge Slack, just go to forgeutah.tech and click the Join Slack button. It's really easy. It's right on the homepage, forgeutah.tech. You can post in the live meetup channel, which is for ongoing talk for whatever meetup is happening. Or you can DM me. Yes, Todd?
Is that a default channel? We should make it that.
It is a default channel, I believe. If not, I have jobs. I should have jobs, live meetup, general, and random. Those are my leads to the segue. It's also a great job board. If anybody here is hiring, you can also announce that right now. You are more than willing to say, hey, my company's hiring. Also post it in Forge Slack. It is the best job board in Utah because it's easy to vet the person that's sharing the job rec because you can DM them. Occasionally they are recruiters, but it's still like not weird because you can DM them. And also you can say, hey, Mariah, will you unlock, like we'll have people show up 15 minutes late to this location and just post in Forge Slack. And it's because so many people are watching that live meetup channel, somebody just gets up and goes and gets the door. It's like really not a big deal, but it's the best way to get a hold of somebody if you're logged out. So we've got the Wi-Fi password. I have contacts for Eric and Chris. I need to get you the link. Do you happen to be on Forge Slack or what?
I think so. Let me see if I will want to figure it out.
If not, I can text it. Like I can text it to you. I can do whatever you want. Who wants to go first? Oh, I need to send you the link.
Forge Utah Slack.
That's us. I'm an admin of that Slack, so I really want you to
Channel should
join.
I be looking at? General?
For me to post the link.
Or you can continue
I'll
Chris
DM
Hall.
Chris.
Hall, Hall.
Don't join. Mariah's drunk with power there. You are.
Mariah, the most famous person for I've never banned anyone in my life, so unless
Other
it's a
reviews.
bot on Twitch. I have done that occasionally. So yeah, if you ever get locked outside a building or you show up on the wrong date, which has also happened, you're in the right place. Come on in. Forge Slack. ForgeUtah.tech, click join Slack. Hey. Who wants to go first?
I can break the ice, but it also me, so.
Yeah, I have to. So just, I spelled you on LinkedIn. I can also add whoever. These mics are always on. You see these things right here, these green boxes. These are the mics. So we'll also get any questions if you have anything. Is that, I'll take it on LinkedIn. Do you want
Yeah, just
to do
found
a
it.
different way?
I just found it. It's good.
Okay.
Or just do it. Just start. Just
Yeah, if you don't want to stand up here, you can just share your screen. I'll stop sharing mine.
I kind of do want to face people, so
Yes.
I was going to set up my phone and actually record the screen.
I found this one.
Just like separate.
I'm too old for this shit, so
I don't like.
I'm stuck with this. I own 3 of them. So they can't be ours.
I don't want like this camera.
Fantastic.
Whatever it is.
Literally attached to your desk.
Well, I was not attached, but
But I
it's
guess
just
that's
really,
where you put it.
like I'll actually just sit right here.
I get what you're
You don't have to. You don't have to be able to bring it all.
Got the tripod mounting kit. It was on the bottom. And
so
so
we
I
just
got
gotta make sure that-
Gripped the
So you're just like sitting back.
What was the name of the Slack channel again?
Like,
Or
fall
go
asleep.
for what? Like, are you on Forge Slack and you're just looking for channels, or do you want to get added to the Forge channel?
Yeah.
Just go to the ForgeUtah.tech. That's the website. That's the URL, and click on the join Slack.
Little pod.
I do?
Right about there.
Yeah, I do. Oh, I'm
You're
turning.
literally holding it.
It's not its name though.
Okay.
The generic one, but yeah, I do. I have 2 of them. They come in handy when you just need.
I agree.
hopefully I'm the slowest one getting set up.
You're fine.
Should I have my mic on to like record audio, or is that?
No, the room records audio.
So I'll have the mic muted.
Apple's finally started.
Nice. Should I just go?
Yeah, you're good to go.
Well, hi everybody. Thanks for coming. I'm Eric. It's great to meet you guys. And when I say that, I mean after, because I don't know that we've met yet. So, my manager and I, John Daniels, we both actually went to Netflix a couple weeks ago to talk about the ML platform that we're building where we work, which is called MLOps. So I have some slides from that. I wasn't thinking I'd give the exact same presentation here that we gave there, but like I think I'll fly over it, and then if you guys just want to do some Q&A, I'd be happy to like answer questions and maybe ask the room some questions too. So before I get into it really, so like I work at Ben Labs. Chaz right there in the black shirt works at Ben Labs, and then so does Jay. And we're not hiring now, but like really like to hire locally when we can, like because like for example, the three of us all hung out at my house today, which I think we're calling the American Fork office now. So like I don't know, we're pretty close, and it's fun to be connected to people who are local. So so what is this talk? It's about so I just by show of hands, like does anyone work in data science now, or like do you consider yourself in the data science space? Okay, and then like also does anyone like decidedly not work anywhere near data science? Like okay, cool. So like do we have any like non-technical people too? Like would you consider yourself non-technical? Okay, awesome. So it looks like mostly technical group. Okay, so basically like I think I'll orient this more towards the technical side, but basically there's a lot of MLOps tools out there, like tools that can help you like train models, put them in production, like serve them somehow. Could be like in a REST API or something like that. And a big part of the problem space too is like, well, yes, there are tools that help you get data science things into products. Some of the tools are more ergonomic than others, so some of them are like really clunky. So we at Ben Labs like have been working on this kind of thing for like going on 5 years now, and our tool set has seen some changes over time. And so like in our most recent iteration, we picked some tools that I consider to be like some really good, really modern tools. And so I want to show you like how workflow looks. So, but to set context, like who is Ben? We are the reason Tom Cruise wears Ray-Ban sunglasses, and the reason James Bond drove a BMW in previous iterations. And there's a pink General Motors car in the Barbie movie. And like into the Spider-Verse movie, there's like a VR Spider Girl. She like wears a VR headset and she's like eating a bag of Fritos when she sits in her chair. So we placed that. So basically we help brand deals happen. Like there are companies that want to advertise their products, and traditional advertising is like really disruptive and annoying. And so we help companies find like the best YouTuber to place their product with, or the best thing in Hollywood or Netflix show. So on the right, you can see this is like a thumbnail analyzer that we have for YouTube. So like you can A/B test using our tool, like different thumbnails, for example, and like here we're like doing a regression on what we think the click-through rate for a given thumbnail is, and like there's kind of like a heat map in there explaining like why the regression, like what it latched onto, what it did. So anyway, this is all just to say we're sort of in this space. So here's the platformy part of the doc. So how did we get where we are today? We use AWS, and I'm pretty sure most groups use AWS or one of the big clouds. And so like to get our ML products like out there running, we had like made these big compositions of like AWS services. Like there were some S3 buckets in there and some containers and some like custom in-house CLI tools that we built, and it all sort of added up to this like stack that we could use to deploy REST APIs and batch jobs on AWS, like with GPUs and stuff. But it was really complicated. That's really what this slide is meant to show. It was a lot of stuff. It was a lot of cognitive load. It's hard to learn. So, and this is our platform team now. There's 3 people, and Jay's one of them, and I'm one of them. And it got to a point where the complexity sort of got ahead of us, and we couldn't add new features to our platform with the 3 of us as fast as the data scientists wanted to. So we decided to simplify with we went out and bought 2 open source tools and got the vendor support for them. So I'll maybe talk a tiny bit about these, but I think I'll skip mostly past it. But what were we optimizing for when we did that? There's a million tools out there, so you kind of have to pick what's important to you. We decided that reproducibility was important to us. In most settings, I don't think this needs much introduction. I think I'll skip past that here. Also, automation. Like there's this concept of like maturity for a data science product, like going from like every single thing about deploying this thing and getting inferences like manual to everything's completely automated. So like there's a certain company setting where like people don't use Git. They're like emailing each other like model weights or data sets. You know, like they're trading CSV files back and forth. And like what do you mean? Where's the code? Like what do you mean? Like what dependencies did I use to even create this model in the first place? Like it worked on my machine, not yours. So like, and in the automated world, like training's done automatically. Detecting like quality issues with your model is done automatically. Same with like deployments and serving and all that. So our thought was it would be nice is if it were really, really easy to like make a given product like fully automated. But we also acknowledge too that like there's a lot of data science projects and most of them fail. And so like I don't think we were so caught up in making everything really polished and automated. We just wanted a straightforward way to make the ones polished, like when we found that they were a good fit. So like, for example, like Stable Diffusion, you know, could generate images and stuff. And so we were like, oh, we could like generate YouTube thumbnails with Stable Diffusion. And so we were doing this thing where we'd fine tune Stable Diffusion like with like a data set of like people's faces, right? So we could try to like generate a thumbnail that had like your face in it, and it just didn't work. Like, so I think there's probably things we could do to optimize this, but the sad thing is like me and a guy on our team actually spent like a quarter getting this model like in production, and I would just argue that wasn't a great use of time. So okay, the last thing is like there's a lot of tools in the MLOps space, like tons. Like I don't have the diagram, but I think it's something like technically there are more than like 2,000 different like SaaS tools you could string together to create an MLOps stack right now. And also now that like generative stuff is a thing, like OpenAI endpoints and Hugging Face models and like I don't know, Stable Diffusion, all that sort of world. I feel like a lot of data science teams have left where the majority of work is training like regression models and classification models. Like that's what it used to be. And now they're kind of like grabbing off the shelf things and composing them. And so like, I don't even know. I don't know where the space is going. All I know is like as a platform team, we don't ever want to be like a blocker. If a data scientist comes to us and says, "Hey, we want to like grab this model off Stable Diffusion and generate like images for like 1,000 images," you know, so we wanted our stack to be like really flexible to accommodate new use cases as they come up because the space is changing fast. So one of the tools we got for serving is called BentoML. BentoML is assuming a model is like already trained, or assuming you have something like a generative model, or maybe you're hitting an OpenAI endpoint or something like that you're going to use to like actually serve inferences to a user. BentoML is nice because like you can deploy models with it as a REST API, but you could also make them like a user-defined function in Spark and like send them against big data, or like you can integrate them with Ray. You can use them for batch, for async, for online. So it seemed like this was a really flexible tool, and it was also familiar to us. It kind of feels like Fast API when you use it, if you've heard of that. So there were a lot of reasons we chose it, but you know, let's get past those. It's really efficient. I'll mostly skip past this, but what this is showing is instead of doing inference one at a time as requests come in, like in REST API mode, it actually batches them, and so it does them a lot faster. And so for much lower cost, you can do more inferences, I guess. So normally you'd have to like make a whole async complex architecture if you wanted to get like one-off inferences to be batched, but BentoML just like batches it all in one little service. So it's just really convenient. So last part of the talk, just going through our life cycle. So these are the steps of the data science life cycle here. This is what our data scientists do. So like first they fill out a form which generates some boilerplate code for them. So that's the thing on the left. That's like, this is meant to represent like a workstation. Sorry, a GitHub repository. And then like what they can fill out this form and it like provisions them a VM in the cloud. The cloud VMs are awesome because they're on the same network as like the data stores you have. Like they have all the permissions that you would probably be using in production. If you want to use a GPU, like your laptop probably doesn't have a GPU, but the remote workstations do. And the download speeds are really fast because like presumably like maybe your data is in AWS, and so if your workstation's in AWS too, then like it doesn't have to travel across the internet to like download stuff. So that's cool. We'll skip past this. So basically, how the workflow works is we have a data scientist fill out like a single Python file, which has this DAG, these steps to like load some data and train a model. And then they can like use an experiment tracker that we have. Like we're using Metaflow to be this DAG part and to be our experiment tracker. But there's other ones that this could integrate with nicely. So like this is a picture of ClearML, but so once they have that DAG to train their model, this right here, this code snippet in the top, this is like all this is very minimal. This is kind of like hello world level example, but like this is kind of to show this is how much code it kind of takes to define like a REST API using the Bento ML framework. So it's like it's pretty minimal, which is nice. And here I'm just showing that it serves as a REST API, but this same code here actually, no changes could be on Spark or it could be with Dask, or, you know, so like you could take this code, write it once and deploy it in like a variety of places. Once they have that train flow and once they've like written this Bento ML code right here, they fill out 2 steps of a DAG that we've written for them. One to load test their model and another to maybe do like some qualitative tests. And once they have those 2 things, let's see, I'll skip to the end here. Like, if you wanted to get to full automation, you could maybe have like your train flow trigger your deploy flow. Like maybe you could do like automated model selection, like in training. And like, if you wanted to like automatically refresh your model, if you like to react to performance degradation, like there's ways that you could like do an event-based trigger to maybe trigger flows. So you could trigger like the training DAG, that would work. And so if you had these 2 artifacts, I guess, like you wrote all of this training flow, you filled out 2 steps in the deploy flow, you can string those together with triggers and you've reached 100% automation for your product. So that's, I don't know, that's cool. It's fairly straightforward. So it's a pretty nice workflow, and like for us, it does achieve these things. And like, I don't know that it doesn't necessarily use the fanciest tools in any given MLOps category, but like it's pretty modular. And if like, you know, let's say you wanted to use a different experiment tracker, that's just a code change here in the train step. Or let's say you wanted to use a specific monitoring tool, have that give you different triggers, you know? So like we can like, it's very modular. We can like add to this, you know, as our needs grow in the future. So that is, that's it. How did I do on time? Do you have time for Q&A or should we just pass it?
I don't care.
Okay. Yeah. Does anyone like, so this is the talk we gave. It's cool because like, because we gave this talk publicly at Netflix, we're in a place where we can actually tell you all the tools that we're using at Ben and even our workflow. So if you wanted, like, we don't even need to sign an NDA. You can just ask us questions about like how to do MLOps. So now's kind of a good chance to do that if you want. Otherwise, yes. So does anyone know someone
You
ask?
said plug Metaflow. Why did you pick that?
Oh yeah. So there's a lot of tools to write DAGs. We also use Dagster at Ben, and I think Dagster, like I'd say Dagster beats Airflow. I think it would beat Prefect. I think it beats most of the other DAG tools. But we didn't choose it for data science, and it was because it didn't easily support using GPUs, and it didn't have great like Metaflow is like you can tell it's built for data scientists. So like all of the DAGs you write have like perfect reproducibility built in, and Dagster's not really like traditional software engineering doesn't have as tight reproducibility needs. Anyway, so
What do you mean by reproducibility?
so do you kind of generally know like that term? Like
Depending on the context.
well, sorry, I'm just wondering if maybe I should define from scratch. So like basically like if you train a model on your machine, that model's like doing some math, you know, like and it's really important that the math that happened on your machine during training time is like the same math that it's doing in production. Because like if on your machine you're like multiplying the width of someone's face by 2, but then in production you don't do that right before you make an inference, then you know your production inference might be like garbage. And so that math can like let's say like a really common machine learning library is like scikit-learn, right? So like scikit-learn changes versions all the time, and sometimes when they change versions, they change the underlying algorithms that like the training is doing. So like it could be like versions of libraries you're using. It could be your own code. It could also be like GPU drivers. Like if you're using different GPU drivers, the math, like maybe like the floating point in arithmetic could be like different in prod. Anyway, so that's what I meant by that, I guess. So thinking those things. Yeah. Any others?
Cool. Let's give Eric a round of applause. Okay, so we've got Chris and Chris, or me. So if you want to go first, Chris.
Yeah.
That's not usually the most popular name you've reached yet.
Super awkward if I sit right where you
Please do. It's a good seat. Here, I'll take your spot.
It's like it's built.
I'll host your Kafka for you.
So I've been playing with a model from OpenAI that's a few years old, like 3 years old, called CLIP. It stands for Contrastive Language Image Pre-training. And so it's a model that takes images or text as input and it creates a vector embedding from that. So just a sequence of numbers. And you can store that in a vector database. And the idea is that if you have an image represented by a vector, the text description of that image should match in vector space. You can use it for all kinds of things. And I read a great blog article that I summarized a little bit and shared, but I've been playing with this a little bit on my own house for a few years. And it has all kinds of applications. So classification, tracking, image ranking, image similarity, image search, image generation. It's used in the training of stable diffusion models like DALL-E, image captioning, robotics control, and there are applications in video indexing. So for classification, one of the things they showed when they came out with this model is that it generalizes really well. It was one of the first foundation models that I was aware of. And so they trained the model by taking a bunch of images and the text off of the internet and mashing those up and kind of minimizing the distance between matching images and text. And then that's how they learned the vector embeddings. But then to create a classifier, they take some classification challenge like Food 101, and they would create a prompt for it, like a photo of guacamole, a type of food, a photo of ceviche, a type of food, and they do that for all of the classes in that classification challenge. And then they would compare the distance, and it did really well without ever being trained on the training data for that classification challenge. So really cool and generalizes really well. They tried it on tons of different data sets. I've used it for image search at my house, so I can search for bicycles and it comes up with pictures of my kids riding their bikes on the driveway. I can search for wet cement and it shows when it's rained. I can search for sunset and it shows sunsets. So just all kinds of cool things you can do with it. Another application was image similarity. So these images have different watermarks, but their vector embeddings are still very similar because the semantic meaning of the images is essentially the same. So it's a way to detect like these changes in watermarks. Another cool thing that somebody did with it is they built a Pictionary app. So the Pictionary gives you a word like tractor in this example. Yes.
Are your slides supposed to be changing?
Oh, yes, they are. Thank you.
I mean, it all made sense because you're so good at describing things. So.
Well, thank you. I'm gonna try sharing differently. Say something. It's on a different screen. Okay, so just a quick diagram of the embedding process. We've got our text, we've got our image, they go to the same model and it creates the vector embedding, which can then be stored in a database. Talking about classification, so this is the picture that goes with that. We've got the food challenge where it was able to successfully identify guacamole. We've also got an airplane classification challenge. satellite imagery competition challenge, and I don't know what this top right one is, but the Sun 397 challenge. So these are pretty diverse classification tasks, but they use the same model and got really good, comparable to state-of-the-art results on all of these at the time. This is a picture of my house with different search terms. So searching bicycles, I can get my kids riding bikes, wet cement, sunset, all kinds of things I can search. Here's the watermark thing I was talking about. And here is the tractor thing I was talking about. So you get a word tractor, it creates the vector embedding for tractor, and then everybody draws their tractor and it creates vector embeddings for each of those. The best match is the person who drew the best tractor. And so you can kind of automate the judging for the dictionary. Kind of cool. Another thing people did with it is tracking. So what they do is they detect each of the fish in the image, then they create a vector embedding for each fish, and then they go to the next frame, do the same thing, and then they match the vector embeddings to see which fish matches which fish, and the best match is the same fish, and so that's a way to track fish. Not a cheap way, but you can do it that way, which is kind of cool. You can corrupt images, and it can still predict things pretty well. So there are data sets where they have added in a bunch of Gaussian noise or Gaussian blur, and it still does pretty well at these challenges. You can hook it up with GPT-2, and then you can do image captioning. So you feed GPT-2 the vector embedding, and I guess that's the same generation of model, so it can understand the vector embedding directly and tell you what's in the image.
I think this is funny. Do you know, is clip an encoder or a decoder?
It's an encoder. It encodes the vector.
You know if GPT-2 is an encoder or a decoder?
I would think it does both, but
It's a decoder only.
only
So Arian clip with GPT-2 is the equivalent to 5. It's just a full transformer system where you feed the output of an encoder to a decoder.
Oh,
Fun.
yeah, I like that. Thanks for the comments. Yeah, so I think you could also hook this up and ask GPT-2 questions about the image, and it would give intelligent responses. Dolly is the old model used for image generation. They have cooler models now, but if you look at how it was trained, they essentially just add a bunch of noise to an image. And then at each of these timestamps, they're feeding in the vector embeddings so that the model learns to use the vector embeddings to reverse the noise. And then once you've trained the model, and it can go from step T2 to T1 pretty well and T3 to T2, then you can just give it a completely static image, noisy image, and have it generate a car or whatever your vector embedding is of. So that's kind of, this is just showing how the vector embeddings feed into it. And they've also used it in robotics to perform different tasks. I know. Yeah, so it's a way to give robots vision. So these are a few links I used to prepare it. This blog on RoboFlow is pretty cool, and it's a fun model to play with. I've been playing with vector databases for my work, which is why I'm interested in coming here. So I'm interested if people have experience with different vector databases. I played with ChromaDB and Milvus, but if people have played with other databases or want to talk shop, that would be fun. So that's my spiel. Sorry for the technical difficulty.
You're good.
Chris?
Yeah, I can go.
Did I miss Q&A?
Do you have questions for the other Chris?
We should do that.
Okay, if there's questions for Chris one,
Yeah.
So you mentioned like a ton of different applications, which is perfect, but like what have you found is the most useful as like a person messing around with Clip just in your personal life?
So I am really interested in using it for image search. So I guess I didn't give my bio, but I work at Vivint Smart Home and we have lots of video data and it's really painful to search through as a customer. We dog food things, so just searching through my own data is painful, but this makes it a lot less
You
painful.
run into problems where you don't know what you're searching for, and so you aren't sure what to type in or get around it.
Yeah, I mean, there certainly is that, and there's also a prompt engineering problem to this. Like, if you search mowing the lawn, it might not work as well as a man mowing the lawn or somebody mowing the lawn, which is interesting, but it makes finding what you're searching for more difficult.
Rocks, thank you.
We have a thing at work that does essentially that for our offices where like we know York is his name, but I won't use that. Joe is wearing
his name.
a blue shirt today, and I want to know when he left the office or if he left the office. I can just go to the camera system and just like ask that question, and it'll come up like, "Oh yeah, this is when," and like you can timestamp it and everything. It's pretty cool. So you're on the right track. It's doable.
With ChromaDB, one of the things you can do is add metadata. So we have tons of metadata about like time of day, what our camera thought it saw, and things like that. And so that's another thing we can filter by to help narrow things down. Like maybe, something happened between 8 and 9 last night, and currently how we search for things is just scrubbing through the video. So you're essentially going through an hour of video, but with this, you could try a bunch of different searches. It's really fast and you can get results quickly.
You said on the tracking fish thing, you're like, this would be an expensive way to track. Like, is Clip compute heavy? Like why is that?
Yeah, it's a lot heavier than a detector or your typical tracker. So,
Okay.
but it's a
do you have, like, point
smaller
of
model
reference?
relative to
Reddy's YOLO is the point of reference. That's what you should look at.
And then the other one is like, so
Light Track is what we have been playing with for tracking. It's a state of the art tracker, and it's in within your model that you like.
nice. And then you mentioned ChromaDB. Like, do you like a particular vector database? Like, do you have recommendations? Like,
ChromaDB is really nice to get started with. I feel like some parts of it scale well, but the whole searching with custom metadata and vector search together doesn't work well. Like it works okay, but it's kind of slow. But vector search is really fast and metadata search is really fast. It's just when you try to combine them, it's slow.
this is off. I don't know. You don't have to have a great answer, but like, if you were to compare it to Pinecone, like any obvious pros and cons, like.
Open source is something I like. It's all implemented in Python. Yeah, Pinecone seems cool, but it's mostly deployed in the cloud, right? It's this you can run local, which I'm interested in maybe running it on device or on the edge. So, but you can run it in the cloud, and they're working on making it more scalable than it currently is. Yeah,
Something you hope to be able to deploy on devices eventually? Like,
that's the dream. I'm trying to pitch it internally, but yeah, working through some obstacles.
So like vivid cameras, could like run Clip embeddings, and you use that for search, or like.
Yeah, something like that. Maybe it's not Clip, maybe it's another model, but tinkering around with it. This is kind of been a hobby for a few years. Yeah, since the few years ago that I started playing with this, vector databases seem to have gotten a lot better because of all the LLM generative AI stuff that's been happening the past couple years. So it's cool, exciting times.
Okay, cool. So, we talked about chroma, so, frick. Error has occurred when screen sharing.
Was it your Chrome?
I'm not sure.
Oh, well, that's why, because, well, wait, come on.
I
I
know.
don't like to do this like Firefox.
There we go.
Okay, so let's take a look at this. Actually, we're
Turn the lights all the way up for that screen.
sorry. Gonna have to do anything if I raise my brightness.
You're gonna have to.
Well, it's just the contrast. It is the light that comes in from the windows. It kills the contrast.
Yeah.
So, see, it's like, it's
Well,
the window.
I wanted to kind of go through a project with you guys. This is like a highly abstracted version of something that we just deployed last week. It uses Chroma DB, so we can talk about that if we want. But I mostly wanted to just kind of give you guys an overview of all the stuff that I never hear anyone ask questions about with the data science project that they really should. So I'll tell you why this is like cool. If we scroll down, see what model are we using? So I spent a long time last week. Can you guys see this okay?
Bigger, please.
All right, I'll read it for you. I spent a really long time last week.
Maybe like 2x the size. It's like plus 10 times.
So this computer already just asked me to make it bigger.
We're gonna ask you to do something that you're really gonna hate, Chris. You should switch to light mode.
Switch to the light. Please do not switch to light mode. Okay. This is Llama 3 70B Instruct, and I spent a good amount of time quantizing it to 1 bit last week. So it runs on this laptop, which is awesome, very cool. And we're also using the Snowflake Arctic embed. And what everyone seems to care about is like, what model am I throwing in there, right? So let's talk a little bit more about the details. Like what is this actually doing? This function is called create text for vector store from XML, right? What do you think that does? Oh my gosh. So we downloaded, or this is not, I downloaded, this is not related to my work at all. I downloaded the entire text of Wikipedia, and this is just the abstracts from the XML that I'm saving as a file. This is the first thing that I feel like needs to be talked about because I've talked about it so many times with different data science teams. Please write your stuff to files, like save it after you do it once. This function takes 6 minutes to run. Don't run it more than 1 time, right? When it's done, write it to a file. If that feels basic, awesome. You're ahead of the curve. That's amazing. We have some helper functions for like formatting the docs for RAG. And then this is pretty simple, just like spinning up a Chroma DB using recursive character text splitter. But this is another thing right here, some memory management, right? If we find that we already have a Chroma database, do not do the recursive text splitting. Do not recreate the database. Just like load it from what you already have. Never do it more than once. Just create it the 1 time. And unless you find that it is super not working, save it and then don't ever deal with it again. And again, if this is feeling basic, you're ahead of the curve. That's awesome. You're doing great. It's just applying engineering principles to data science. This is another thing. Always use custom prompts. I don't necessarily recommend LangChain for production. In fact, I really vehemently don't recommend LangChain for production, but I do recommend LangChain for prototyping, right? You should build out your own version of this for production, but LangChain can get you there, like probably from a 0 to about a 0.85 or maybe a 0.9 to just having a product so that people can visualize it. They can see what it can do. It's pretty bloaty and it runs pretty slowly. So, but it's very nice to just like pull tools together so you can see what that final flow needs to look like. In this case, I'm talking about always use custom prompts. Llama 3 has a completely different prompt structure than Llama 2. pay attention to that, right? We're doing begin of text, header IDs, like all of this stuff. It's, I've played around with this a little bit. If you screw with this system prompt, like it drastically affects the performance. If you even change it to be like you're an expert at X or Y, like it'll change the entire performance of the model. That should go down here under the user section where you tell it what its role is. You can still do it, but like don't mess with the system prompt with this the way that you can with Llama 2. And then ultimately the RAG chain. So here there are two versions. There's one DSPY version, which if you use DSPY, you're going to understand immediately why. I want to plug this and throw this in here. DSPY is an open source framework. If you don't know what it stands for, neither do the creators. It's just DSPY. They have no idea what it stands for. It's a framework for essentially doing recursive machine learning on your prompting to figure out what is the best prompt, even if it's not human readable, for getting the exact output in the exact format that you want. Really cool. But then, yeah, we load the database, load the models. I had this timed before, so I'm just going to give you some stats for embedding. This, the Snowflake Arctic embed model, you can embed about 5 prompts or about 100 prompts every 5 seconds. Pretty fast, but like put that in context of Wikipedia. How many Wikipedia articles do you think there are?
There's 6 million in English, isn't that right?
Yeah, there's 6 million in English. And we're cutting it down to a subset that we think is useful. That ended up being about 2,700,000. Does anyone want to hazard a guess of to how long it takes to make a whole Chroma DB embedding of that?
68 seconds.
68 seconds.
Oh, that's
It
too
was
fast.
37 hours of literally just letting Snowflake embed, right? And the funny thing is, you get out of it, and this is my biggest complaint about Chroma, is it won't immediately tell you if there's anything going on with your process. We have the entire vector database complete. But according to Chroma, according to the actual vector count, it says there are still only 0 records in it. That's not true, but they could work on their little count interface a teensy bit better. I decided to ask it, who is Jody Hildebrandt and why is her house worth 5.5 million? Because that was fun. Turns out there's more than one Jody Hildebrandt and it knows about all of them. But the one I was talking about is the one in St. George who's selling her house. But it got it right with an Australian social media personality, and then when you change it to, if you just add St. George, it's right, gets all the details right. Very cool. Is there anything you guys think that I missed for this process? I don't mean that as a rhetorical question, but I kind of want to dig into the things that you guys care about so that you can actually deploy this, or do something similar. What questions do you have about how to get from 0 to a working prototype?
If you're Chris, it takes 10 minutes, and if you're a normal person, it takes 10 hours. So no dumb question here. He's also very aware of the difference.
Did you run this all locally?
I did run it all locally, yeah. Yeah, strongly recommend Llama CPP. You see I have up here Llama CPP and Hugging Face embeddings. If you're not familiar with Llama CPP, it's really helpful to get familiar with it because it opens up the door to a whole bunch of other frameworks that people have built on top of it that will just immediately make sense. Stuff like OLLAMA or COBOL, or there's a bunch of them.
What was Snowflake's contribution here? I didn't understand that.
Beautiful. All right, I have a whole other notebook for you. So
For talk number 2.
Time number 2, yeah. Snowflake, they created the embedding model. That was their contribution here. But Snowflake also had the contribution of storing the data, right? Nobody asked about Llama 3 fine tuning, which we did. I don't recommend using any open source model completely out of the box. Immediately fine tune it. And we used Snorkel and Snowflake together in order to actually make a working, I guess, a data set for the model to train off of. And so this actually took the majority of our time. It took 37 hours to embed, but it took a whole week beforehand to perform all of the labeling functions. And here I'm just going through like, this is literally just transformation functions where we take a data set, that's just chain of thought and severely augment it. Like, we use Spacey to pre-process everything, literally Spacey preprocessor. One of the things that people generally get confused about that I'm just going to tell you, with the preprocessor, the text field is the one that you input, and the doc field is not supposed to be a field that's already in your data set. That's supposed to be a new one that Snorkel will write. Just so you know, if you ever want to replicate this. But the reason that Snorkel rocks is they allow you to do programmatic labeling and transformation functions so that you don't have to do all of that labeling process manually, right? This is where the majority of our time was spent, was creating transformation functions like this one, which detects if there are multiple adjectives in a given utterance and just swaps their places, or this one, which will replace a verb with a synonym, or this one, which will replace a noun with a synonym, or this one, which will replace an adjective with a synonym, right? Those are all interchangeable word classes within English, and so we can immediately assume that a synonym would be grammatically correct in that area, even if it doesn't semantically or pragmatically make sense in that utterance. But running this is actually way quicker. Oh shoot, it didn't say the time. Oh yeah, it did. It only took 8 minutes and 40 seconds to go through the entire data set that we were using. And here's the awesome output. The original training set size had 74,771 examples, which roughly equates to about 100 million tokens. And we were able to get an augmented training set, which more than doubled that with 165,000. And it didn't exactly double the token amount, but it did get us from 100 million to about 170 million, which is cool. Training on multiple tokens makes your model smarter. Does anyone have any idea of like when we would want to use the original training set versus the augmented training set?
You don't know any better.
You don't know any better?
When you don't know any better.
Oh, when you don't know any better?
Yes.
Oh, when, because we keep them both, right? And I use them both. When do you think I use the original one versus the augmented one? Oh, hey, that's a good, I didn't even think of that. That's a better answer than I was giving.
It's like test the increase in performance that your augmentation actually gave you.
Absolutely, yes. Testing it, and then as well, we use the augmented one for pre-training or simulating pre-training. Because in pre-training, the model is just learning about connections between words. It does not care about what any of them mean or what the labels are or what the eventual output is but we use the original one for the actual fine tune. Because we need to make sure that all of the examples that we're giving it to fine tune on make sense semantically and pragmatically, and we already checked that with the original one. Okay, perfect. So
Tell us more about the quantization process from 8 bits to 1 bit. What did the change in size of your binary?
Oh, good question.
Some of the specs that you saw.
So Llama 370B is 280 gigabytes in 32-bit quantization. In 1-bit quantization, it is 16.5. So immediate boost, right? It can run on this. It can run on my computer at home. In fact, I have a server that just has a 3090 in it that it just runs on that constantly. And the cool thing is testing the performance. It's very similar to just quantizing it down to 16-bit, that P60. It's almost negligible how different it is. It does have higher perplexity, which is a problem for generating longer sequences. However, that initial performance of just like, hey, who is this person? Or like answering my 3-year-old's questions about dinosaurs, easy, easy. And that quantization process specifically for 1-bit is turning each weight into a ternary operator as opposed to the initial 32-bit sequence tensor that it is in the beginning. And that's just -1, 0, or 1. And overall, it works really well. I strongly recommend you guys check it out, test it out. Does that help? Do you want to know how I did it? Do you want to know like
I'd love to hear more about how you did it.
Llama CPP has a quantized script. There's a new commit that is not, it's not one of the releases. So if you get clone, you won't be able to get it. But if you get clone with the exact commit, you can get the new one, or you can just wait for it to come out. But it's so you just have to build Llama CPP and then you tell it to put already in the GGUF format into this 1-bit quantization. Doesn't take too long. Yeah, it was about 3 minutes of a wait. It's pretty great. Go ahead.
Yeah, so with this being like it's pretty foreign to me, if there was one or two libraries, you'd say like, hey, dive into this one and learn some more on blank. What would you recommend?
Oh, sick. Yeah. Snorkel, LangChain, Llama CPP.
And why did you say LangChain you vehemently like oppose it in production? Besides, you said it's bloated and slow. Are there any other reasons?
It is bloated and slow. It's a Python only framework, but it doesn't super contribute to a lot of stuff. It's abstracting and wrapping other frameworks. So like if we go back here, you know, I'm importing Chroma from their vector stores. Awesome. It's a wrapper around the Chroma package. Or I'm importing Llama CPP. Awesome. That is a wrapper around the Llama CPP Python package. It's more worth it to like once you're familiar with LangChain and you're familiar with how these projects fit together, how they work, it's more worth it to dive right into the packages that they're wrapping so that you're more familiar with them and you can understand more about what's going on under the hood. So that's why I recommend LangChain. Fantastic place to start, fantastic place to like dive in, get your feet wet, like build stuff. And then for production, you should write your own that's more efficient.
Performance, it doesn't exist in tooling. It exists when you write your own code, so.
Exactly. And beyond that, like, I mean, I talked about embeddings, that embedding process, that's more than a day that it's going through, right? You can't really afford to mess up in the LLM space because you lose tons of time for what you're doing. If you look at the chinchilla scaling laws, you're supposed to have 20 times your number of tokens to parameters. So if you're training 1 billion parameters, you should train it on 20 billion tokens. This was 170 million tokens and it was taking 37 hours. If you're training on 20 billion, that's weeks and months. You know, it's less about having the GPUs and having access to the GPUs because everyone can use AWS or GCP. It's more about allocating that number of GPUs for the whole amount of time that you're going to need them to do all the math, right? Cool. Thanks. Any other questions? Go
What do
ahead.
you recommend instead of LangChain, or is it just kind of like customized?
Oh,
Hooking up all the bits and pieces together in production.
yeah. LangChain is going to help you with the MLE experience more than the data science experience. If you want more data science, like Hugging Face and PyTorch, definitely look into those. Those are the biggest ones that I recommend. LangChain will help you take Hugging Face and PyTorch and put it into an ecosystem of other tools that you can string together or chain together, I think. That's what they like you to call it. Cool. Thanks, guys.
Never mind now. How do you go back to Zoom? Is it? No. Here's the button. Back. No, sorry, it's not that. I was button. Share. Tab.
No, Mariah, nobody else felt the need to use the podium.
Computer's already here. So I get fancy slides because I signed over my life to Google. I am Mariah. I am a Google developer expert for Go. That is me. That's it. There's me signing. Oh, I forgot. So I spent last Friday. I didn't work. So while Chris was in the hospital with his wife, while she was trying to have a baby, I was struggling with LangChain, trying to build an LLM bot. Priorities. There was somebody else in chat that could help me out, so
Oh, that's awesome.
you were missed, but not needed. Well, your wife needed you, but you know, you're in the right place. So I spent 5 hours. Like I said, it would have taken Chris 5 minutes. So I spent 5 hours building a bot that takes Twitch chat, pumps it through LangChain, which it might be a Go wrapper of LangChain, but I used Go. Pumps it through LangChain Go into just a generic model I downloaded from the internet because Chris said it was an okay model. And then we got results we pushed them back up to Twitch chat, so it was live running on the live stream, you know.
Rocks.
I know, and it was only 6 hours to get a working prototype. That's not bad. So, why build the bot? Because my Twitch chat sucks. It's usually just crickets. So I figured, you know, it'd be nice to drive engagement, have something that would post a snarky comment if it was silent for too long. You know, people like to say, "What are you doing all the time?" And instead of me having to like repeat it 12 times, it could just comment in chat what you're doing. Because, you know, you introduce it once, but like, you know, also it's a fun thing to build on the stream. So, you know, great idea. So it was pretty easy. Step one, I just had to get Twitch chat. I had this working before, but I had to reset it up. OAuth and all that stuff was fun, but it was really simple, just a line of code. I found a Go library that does it, and this is basically it. On message, so this is just the function that's processing everything. So I just set up on message, and then I'm passing in a function. So functional Go. We're passing in a function. It prints the message to standard out because that was my sanity check. This is not forever going to print it, but you know, my chat's crickets. I'm not clogging up my standard out with messages. It sends it, then we passed it to our LLM, and then that say posted the response, which is RSP, back to the channel name that I gave it, which was my Twitch channel, Soypy Tech, which you can follow, by the way, if you're ever interested in live coding in Go, the best programming language. After that was step 2, run Llama CPP. Why? Because Chris told me that was the easiest one to run. And he also told me not to pay for it. He said, don't pay for Chat GPT. He didn't say they were garbage. He said you could get better results with open source. So, and I bought a $200 refurbished computer just for the sole purpose of running Llama CPP. So, you know, we ran that. So it was pretty easy. Set that up. I downloaded this model and I just pressed serve. Just gonna run an API and hit it with the client, right? So I have a Go thing. It's just hitting an API. And Chris also said clearly I get all my information from one source. That it uses the OpenAI API framework, so it's really easy to plug in, right? Once you have a server running, you're just using a nice little API framework. Step 3, connecting Llama C++ using LangChain. I did not use LangChain. I used LangChain Go, but whatever. This is the LangChain code. I decided, again, because it's crickets, I was just going to do it from single prompt. I don't know. This was an example. I know nothing about how to use LLMs. And whenever I want to do it for fun, I just message Chris and he is like always willing to talk about it. So my goal after I got this working, I already bought his book, LLMs in Production. So I'll start applying the learnings live on the Twitch stream to my Twitch bot, you know, payback because it's advertising. But basically I have the LLM I set up, which points to my server. The temperature was what was set before. The example had this stop word as Armstrong because the prompt was, who was the first man on the moon? And I was like, well, I'll just switch chat in there because Twitch chat. Also, if you ever watch Twitch streams, we refer to chat as chat, so it's kind of like an entity. And so yeah, I just very basic and crude and needs a lot of love, to be fair, but it was that easy to just do a single message. And it probably would have kept up pretty quickly. My goal long term is to take a group of messages and throw that set of messages as an entire body over to the machine. It's talking APIs over to the Llama CPP model, whatever one I end up choosing, and then get a single response for a historical conversation. Anyway, so step 4 was just run everything, and this is what happened. The Shaggy D said, "Tell another story." The bot said, "What story?" It was a dumb bot about a programmer. About compliment me. This is the assistant. Tell a story about a famous streamer. I've heard of several famous streamers, including Ninja Shroud and Dr. Disrespect. Do you want to know about them? LOL. It's quality. Thanks. Hi. This is what happens when you know nothing. It's live on stream, and so I was so proud of myself. Prove that anybody doesn't as I'm a software player, so my big thing is like, how can we get AI tooling into software products? And my proof of concept proves that you can with no knowledge, and it's not bad. Like, it's definitely a bot, but it's not horrible.
You could name it Dad Bot.
Pretty much. So, yeah, and so that's 5-minute lightning talk. Thank you very much. If you ever want to see me work on it live, that's my Twitch handle. Like I said, it was only a 5-hour stream. It's not that bad. And half of the time was figuring out Twitch off, so. Stupid. Anybody have any questions? It was a good story though, huh?
This was awesome. I'm interested in LangChain Go. Because
Me too.
you're not importing packages the same way that you are in Python. Does it just have everything?
That's the thing I don't know about. Let me just.
It's not a wrapper. It's a pure Go implementation.
Yeah, so that's my understanding is it's a pure Go implementation. So that means you don't get the bloat that comes with Python.
Amazing.
I also don't think it's implemented everything that's in the Python one.
I highly doubt it as well.
Because they did not have, well, we can just go there.
Hold on for a sec. You can do LLMs even outside of Python, and you probably should.
Want to know my pet peeve? I think that Python is a very slow language, and we should never use it in anything that we want to be performant.
No.
What I just heard is Python is the best language and you should use it for everything.
Oh, Todd.
That same filter.
So I just so it has chains, it has embeddings. I was over here, so I just went over to LLMs and I picked the open.
We're just seeing your Google Sheet.
Oh, dang it. I only shared a single tab. Let's go share the entire stinking screen. Thank you for letting me know. Wait, did it let me change tabs? Because sometimes it gives you that button.
Should be like top center, right next to stop sharing.
It was dumb. Share the entire screen because that's easier. Can you tell that I stream on Twitch with how large and hard this is to navigate? So this is just the LLMs. As you can see, you had Llama CPP in your LLMs. We don't have that. We do have a local API. I just used Open API, which was fine. And then as far they had examples for everything in their dog. So I went over here and I was like, Open API. I think it was the chat example was the one I ended up pulling out. I don't know. This is the one. This is what I want to implement. So yeah. So let me see. They have a lot. So they have. I didn't want to go back to examples. They had LLMs. They have prompt stuff, which is generic tooling that applies to all of them. Like the thing that I used. Where was that? This is my code, by the way. I haven't even merged it, so. This LLMs generate single prompt is a generic function that can be used in any of the LLM packages. So I just put that in the generic send chat. And then the setup, which you didn't see, was I just did open API with a base URL, plopped in the local. So it's pretty simple. Options you can set up. Oh, that was the base URL. So the docs aren't bad. And yeah, it does use Go, which means it's 75 times faster than Python without trying. So yeah, sorry, I probably didn't answer your question. So yes, it's a Go implementation. It's got a lot of things. It's got vector store connections. So, a bunch of different Chroma, PG vector, Mediate. So yeah, a lot of the tooling. I probably would use this in production naively until I ran into performance issues. That's my opinion as a seasoned Go expert. Use it until it's a bad idea. But it's also not Python, so you're not getting the performance hit. Yeah, any other questions? Oh, I'm done.